Hello, everybody. So, as of today, this is for February 15th, but if they rearrange the schedule, I think it would be February 17th, so don't let the date throw you off. It's still for this assignment, okay? Just they may change when we're actually starting back in live, so it would affect this, so don't let that throw you off. Okay, so in this assignment, you guys are going to ask to rewrite the quadratic function into vertex form. So we've been looking at this. This is standard form. This is vertex form. You've seen it, but we haven't really talked about it. And what you want to do is rewrite this from standard into something that looks like this. Now to do it, I need to kind of zip through these ideas of a perfect square with you real quick. There's a pattern I need you to pick up on and believe and trust by verification with me that this thing actually works, that I'm not just making this up and having you believe it without seeing it, okay? So when something is squared in a parenthesis like that, you can't just distribute it. It's not x squared minus 9. No, you can't do that, okay? It doesn't work that way. So that's the first thing you got to believe. Second thing, if I FOIL this out, I get x squared minus 3x plus 9. And this one would be x squared plus 5x plus 5x plus 25. This one would be x squared minus 7x plus 49. And this would be x squared plus, 4x. Sorry, I'm not being as fluent there as I should have been. Okay, a couple things to point out in this pattern. First, the beginning thing is always a square, and so is the end. The end is always a square. And notice it's a square of this number. Okay? And it doesn't matter if it was positive or negative in the parenthesis. The end number is always positive. Always. Always, always. Notice the middle. There's two of them. There's exactly two. And you should notice each individual one of those is a product of the first times the second. So let me look at this answer. X squared minus 6x plus 9. X squared plus 10x plus 25. X squared minus 14x plus 49. X squared plus 8x plus 16. What I said just a minute ago, individually, what the O and the I work out to is if you look at it in this, it's called a perfect square. It's a product of the first times the second. It's a product of the first thing times the second thing. Individually, that's what there are. And there are two of them. So there's a fact that has to come from this. So let's make one up now. What I want you to see is, instead of foiling, you know the first thing is just going to be the first times the first. Well, if I wrote that out as x minus 6 times x minus 6, you know the first times the first is going to be x squared. So I'm just squaring this first thing. The middle, there's going to be two of these things multiplied together. X times minus 6 and x times minus 6. There's two of them. So just multiply these together and double it. Square the last thing. So let me do this again. Square the first thing. Multiply together negative 11x and double it. Square the last thing. There you go. Okay. If you need to see it again, square the first thing. Multiply together and double. Square the last thing. Okay. Now, there's another piece you need to get from what I just did. Looking at the answers here. What is half of 8? Square it. It's the end. What's half of negative 14? Square it. It's the end. Half of 10 is 5, squared is 25. Half of negative 6 is negative 3, squared it's 9. Half the middle squared is the end. 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 Okay, so this. Half of the middle is 1. Square it. It's 1. This right now is a perfect square. It filed, I know I haven't dealt with that 8, don't get me wrong. If this is a perfect square, it has a pattern. Half the middle squared is the end. Half the middle squared is the end. I just created a perfect square with this much. Now, I realize I can't just add 1 to this and claim it's the original equation. But if I subtract 1 right after it, I really haven't done anything. And the plus 8 is still here. I haven't done anything to this equation. I've added 1 and subtracted 1. So it's still this equation. I added 1, subtracted 1. However, this much is now a perfect square. And I can factor that back into this. This much is here. This is worth this. So let's try factoring some perfect squares. Let's say I give you x squared plus 6x plus 9. That would, notice half of this is squared is the end. What would that factor back to? Half the middle. If you need proof, x squared plus 3x plus 3x plus 9 is x squared plus 6x plus 9. Half the middle, boom, is there. X squared minus 8x plus 16. Half the middle. Let that sink in. It's just half the middle. Because if you multiply this out, folks, that's x squared minus 4x plus 16. It's x squared minus 8x plus 16. To factor something that's a perfect square, you just take half the middle. And notice half of this number squared is the end number. So this thing is a perfect square. Okay? I want to force a perfect square to happen. Let's try this one. Minus 2x, what's half the middle? Negative 1. Negative 1 squared is positive 1. Add 1, subtract 1. I haven't done anything. And the minus 2 is still there. I took half the middle and squared it to get the end, because that's the pattern of every perfect square. Half the middle squared is the end. Half the middle squared is the end. Okay? So to force it to be a perfect square, I take half the middle, negative 1, square it, add it. And I can't just add a 1 because now it's not balanced. But if I immediately subtract it, then it is balanced. And that much is a perfect square. And that would factor to just half the middle, minus 3. And now that's in vertex form. Okay. Y is equal to x squared minus 6x. Half of negative 6 is negative 3. Negative 3 squared is positive 9. I add 9. I have to balance it by subtracting the 9, and the minus 1 is still there. The first 3 things form a perfect square. And now you just take half the middle. Square it, minus 10. Okay? Now they're going to be a bit of a jerk. And when you take half the middle, it doesn't come out nicely. They were all whole numbers before. So now they're going to be jerks, and you get a decimal. So x squared plus 3x. Half the middle is 1.5. 1.5 squared is what, 2 1/4? Is it? Yes. 2.25. So I have to add 2.25. Now that's a perfect square. Half the middle squared is this. But I have to subtract it to keep it balanced, plus 3. The first three things form a perfect square. And you factor it by taking half the middle, put a square on it, and then that's plus 0.75. And that's your answer. Same dealio. Half the middle is negative 3.5. Square it. Let's see what that gets you. Oops, I didn't hit enter. 12.25. So I have, and it's always add 12.25, then subtract 12.25, the decimal, plus 2. The first three things form a perfect square. And you factor it by taking half the middle, x minus 3.5. Then that's minus 10.25. Okay, that's your assignment. Let me know what I can do for you. Thank you for your time.